Hello everyone. Today we are going to start the new chapter, which is ratio and proportion. Well, you must know that these two concepts are the concepts that are used mostly in our daily life. We can give a simple example, the one that is given on your book. So people use ratio and proportion every day when they are cooking. For example, to bake a cake, you might need 2 eggs and 125 gram each of sugar, flour, and butter. To make a cake twice as big, all the ingredients needs to be doubled so that they stay in the same proportion and the recipe will still work. Okay, so in each activity that we do, maybe we need to use ratio and proportion. Uh, so let's talk, or let's take the concepts that are most important for it. First of all, it is given this cross number puzzle to your book. I want to complete it on your book. Okay, you have to revise maybe the knowledges that you have taken from grade 6. Okay, by solving these problems you will complete this crossword. Now let's pass or let's make a revision about the ratio that you have taken in previous classes. So what is a ratio? A ratio compares the size of two quantities. Okay, so when we say ratio, it means we have said that we are comparing the size of two or more quantities. For example, in this figure, I have 5 squares and 3 triangles. So if I say what is the ratio of triangles to squares, you will say 3 to 5. If I ask you what is the ratio of squares to triangle, you will say 5 to 3. So there are 5 squares for or per 3 triangle. You can write even like a fraction, like there are 3 triangle over 8 of all figures, or 5 squares over all. Okay, or if you want to compare the number of triangles to squares, you will say there are 3 to 5 or 3 over 5. So ratio can be expressed even in fractions. Okay, 3 to 8 to 5 to 8. And if you remember, even you can compare these two ones. Okay, so if we write 3 to 8, okay, I'm writing the ratio of triangles to squares, 2, 5 to 8. And when we have these equal denominators, this one will be same as 3 to 5. Huh? 3 to 5. Okay, so this one is the ratio. Well, we have equivalent ratios too. For example, in this figure, there are given 6 squares and 4 triangles. So if I ask you what is the ratio of squares in this diagram, the ratio of triangles to squares, you will say 4 to 6. If I ask you what is the ratio of squares to triangle, it will be 6 to 4. But if you see, I have make some of them red and some of them blue. So if I ask you what is the ratio of this red part, you'll say 2 to 3. Huh? So 2 triangles per 3 squares. And it is same as the ratio 4 to 6. Okay, so we can say that the ratios can be simplified to the simplest form. Okay, so for every 2 triangles I have 3 squares, which means for every 4 triangles I will have 6 squares. Okay, and so on. So we have equivalent ratios, or the numbers which show me the same ratio. Well, how can we get them? We get them by simplifying with the highest common factor. Okay, so we simplify the numbers with the highest common factor to get the simplest form of the ratios. In this example, we can see 15 to 25. The highest common factor of 15 and 25 is the number 5. Okay, the factor 5, we know. So if I divide 15 with 5, I will get 3. And if I divide 25 with 5, I will get 5. So the ratio will be 3 to 5. In the same way, we can see the second ratio, 4 to 8 to 12. So I have to find the highest common factor of 4, 8, and 12, and the highest common factor is 4. So I will divide each of this number with 4. So 4 divided by 4 is 1, 16 divided by 4 is 4, and 12 divided by 4 is 3. So the ratio will be 1 to 4 to 3, okay, for this one. In this way, we can get the ratios. Well, let's see example 2 on your book. In what ratio are the side length of triangles? Write the smallest number first and the largest last. Don't forget to simplify the ratios. Okay, so let's write the ratio of the sides for the given triangles. And we have a condition for this one. We have to write the smallest number first and the largest one last. So at this triangle, I have the length 21, 42, and 49. So the ratio of the sides will be 21 to 42. Okay, to 42 to 49. Is this one in its simplest form? No, because the highest common factor of these three numbers is 7. Okay, so I have to divide by 7 each of these numbers. So 21 divided by 7 will be 3. 42 divided by 7 will be 6. And 49 divided by 7 will be 7. So the ratio of the side length for this triangle will be 3 to 6 to 7. Let's see B. It is an isosceles triangle, so this side is 10. From this symbol, I can understand that this one is 10 too. So the ratio will be 10 to 10 to 12. Okay. Is it in the simplest form? No. We know that the highest common factor of 10 and 12 will be what? 2. So I have to divide by 2 each of these numbers. 10 divided by 2 is 5. 5. And 12 divided by 2 is 6. So the ratio of the side length for this triangle will be 5 to 5 to 6. The last one is an equilateral triangle. All the sides are equal. Okay, we can understand from the symbols that are used on the sides. So the ratio of this one will be 7 to 7 to 7. Okay. If we simplify it with what? With 7, of course. I will get the ratio 1 to 1 to 1. Okay, so here we divide it with 7. So the ratio of the side length of this triangle will be 1 to 1 to 1. Always we are going to use the simplest form of the ratios. So we have to simplify them. Okay, it is more easy for us. Let's see exercise 5 now. Ratios in their simplest whole number form will not contain decimals. Okay, it is important that they will be whole numbers. So for example, to find 0.826 as a ratio in its simplest whole number form will be what? First of all, we have to make the decimal number a whole number. To do it, we have to multiply with 10 in this case. So 0.8 times 10 will be 8. If we enlarge one of these numbers, of course, we have to enlarge the second one too. So 6 times 10 will be 60. So we have to keep the same ratio, the equivalence between them. So the ratio is 8 to 60. And this one, if we simplify with 4, will be 2 to 15. Okay. Now let's see the other examples. So let's write this one in the simplest whole number form. 0.5 to 7, it means to make 0.5 a whole number, I have to multiply with 10. Okay, so let's do here. So 0.5, okay, to 7. First of all, I have to multiply with 10. Okay, so times 10. It will be 5 to 70. Okay, 5 to 70. Is this one in the simplest form? No. We know that the highest common factor of 5 and 70 is 5. So now I will divide with 5. Okay, I will divide with 5. And it will be 1 to 70 divided by 5. So it is 120, 14. Okay, 1 to 14. At the second one, so this is the ratio. At the second one, I have 4.9 to 1.4. Okay, at B. Both of them are in decimal form with one decimal after decimal point. So again, I will have to multiply with 10. Okay. So if you multiply with 10, you'll get 49 to 14. Okay. 49 to 14. Here we multiplied with 10. Is this one to the simplest form? So 49 and 14? No. We know that the highest common factor of 49 and 14 will be 7, the number 7. So we'll divide with 7 and the ratio will be 7 to 2. Okay, 7 to 2. So this is the ratio for the second one. At the third one, I have 5 to 6.5 to 3.5. Again, I have one decimal number after decimal point for these numbers. That's why I will multiply again with 10. So it will be 50. Okay, I'm multiplying directly to 65. Okay, to 35. Are they in the simplest form? No, we know that the highest common factor of them will be 5. So we have to divide with 5. Okay, so 50 divided by 5 will be 10. 65 divided by 5 will be 13. And 35 divided by 5 will be 7. So the ratio of this numbers is 10 to 13 to 7. Okay, so in this way you can write the ratios when the numbers that are given are decimal numbers. Sometimes we can have even fractions or percentages, okay, or decimals. So let's see exercise 6. If you have fractions, you can convert these fractions into decimal number, or directly you can equalize the denominators of the numbers and take only the numerators as the ratio. Okay, so I have 1 over 4 to 5. Okay, I have 1 over 4 to 5. So this one has denominator 1. If I think like this, can I make this one's denominator 4? Of course. Okay, so I can write this one as 1 over 4 to, okay, if I enlarge this one by 4, 1 over 4 to 20 over 4. Okay, so the ratio of this one is same as 1 to 20. Okay, 1 to 20. So this ones get simplified, or it means I'm comparing the same amount. Okay, from 4 parts I've taken 1, from 20 parts, from 4 parts I've taken 20. So 1 to 20. Therefore, this one is same, so get simplified. At the second one, we can do the same thing. We can write 2.2 as a fraction if you want, or we can write 1.5 as a decimal. I prefer to write 2.2 as a fraction. So 2.2 will be 22 over 10. Okay, 22 over 10 to 1 over 5. I can equalize the denominators. It means I can make 5 10 by multiplying the fraction with 2. Okay, enlarging the fraction with 2. So the new ratio will be 22 over 10, okay, to 2 over 10. So it is what, since the denominators are equal, 22 to 2. Again, this one can be simplified by 2. So this ratio will be 11 to 1. Okay, 11 to 1. Now I have percentage, decimal, and fraction. We can convert all of them to percentage, all of them to decimal number, or all of them to fractions. Again, I will prefer to convert them into fractions. So 36% is 36 over 100. Okay. 0.6 is 6 over 10. And 3 over 25. So the least common multiple of these denominators will be 100. So I will make the denominators 100. It means I will enlarge the second fraction with 10 and the third one with 4, okay, to make 2500. So the new ratios will be 36 over 100, okay, to 60 over 100, okay, to 12 over 100. So since I equalized the denominators, I can write this fraction, this ratio as 36 to 60, okay, to 12. Again, it is not in its simplest form. Okay, I can divide each number by 12. So 36 divided by 12 will give me 3. 60 divided by 12 will give me 5. And 12 divided by 12 will give me 1. So this ratio will be 3 to 5 to 1. Okay. And the last one, again, we have to equalize the denominators to make them 5, 4, and 3. So the least common multiple of them will be 20 times 3, 60. Okay, so we have to make them 60 and then compare the numerators. Okay, you can complete D. Now let's pass to another thing. It is one of the most important things for ratio. When we write a ratio, the quantities that we compare must be the same units. Okay, they must be in the same units because at the end the ratio has no units. It means they get simplified with each other. So for example, if I have the length of line P 2 centimeter and the length of line Q 13 centimeter, the ratio comparing the length of P to Q won't be 2 to 13, okay? It is 2 centimeter to 13 centimeter. I have to convert them into the same unit. It means both of them into centimeter, of both of them into millimeter. In this case, into millimeter. So 2 times 10 will be 20 millimeter. And now these units get simplified. So of course, I don't have units at the ratio. It is 20 to 30. Okay, this one is too important for you. Let's see another example. It takes James 2 hours, 14 minutes to walk from Lake Pukpuk to Auckland Zoo. It takes him 50 minutes to cycle there. The ratio of walking time to cycling time is. Now, so to walking 2 hours and 14 minutes, and cycling 50 minutes. So the first one, the unit of the first one is hours and minutes. So I have to convert them into minutes. It is 134 minutes to 50 minutes. And it is the ratio 134 to 50 or 67 to 25. Okay, so the units must be same in order to have a ratio. And at the end, we don't have units. Okay, because these ones, the units, get simplified. Now let's see the examples. Write a ratio to compare the mass of the first object with the mass of the second one. So there are given two objects. It means rice with mass 250 grams and the second one 1.5 kilogram. And we have to write a ratio to compare them. So we'll have what? The ratio of 250, okay, grams to 1.5 kilogram. As you see, the units are different, so we have to convert into the same unit. It means I'll make kilogram to gram. So 250 gram so to make kilogram gram, you have to multiply with 1000. So this one will be 1500 gram. Okay, now the units are same, so we can compare these ratios. We can simplify them. It will be 250, okay, to 1500. So if we simplify these ones with 250, we will have 1, 2, 6. Okay, so here we divide it with 250 as highest common factor of 250 and 1500. Okay, so the ratio of these two will be 1 to 6. Okay, let's see exercise 4. We have to use the ratio to compare these quantities. Okay, you are going to complete exercise 4. I will solve only one example. Let's compare 1 week to 4 days. 1 week has how many days? So I have to convert into the same units. It is 7 days. Okay, so I have 7 days to 4 days. So since the units are same now, it will be 7 to 4. Okay, and this one is the simplest form of this ratio. In the same way, you can continue with the others. So exercise 4 will be your homework. Exercise 5 and exercise 6 again is your homework. You have to do what? At exercise 5, Farhan has on his homework has simplified the ratios. So 3 gram to 3 kilogram, he has divided by 3 and the ratio is 1 to 1. 7 centimeter to 85 centimeter, he has divided by 17 and had get the ratio 5 to 1. Okay, so but there is a mistake on these ratios that you have written, and you have to correct this mistake on your notebooks. Okay, so what is this mistake? Gram and kilogram, the units are not same, so you have to correct them. And again, you will use the ratio to compare the quantities. Okay, so you have 5 centimeters squared, 250 millimeters squared. So you have to change or to convert them into the same units. And you remember the scale of converting units. A centimeter squared to millimeter squared, it means you have to multiply with 100. Okay, so you will have 500. Let me do the first one. 500 millimeters square for the first one. Okay, to 250 millimeter squared. Since the units are same, now you have 500, okay, as a ratio to 250, which is, if you divide by 250, 2 to 1. Okay, so this one is the ratio. In the same way, you will continue with the others. Okay, and that's all for today. So you had homework exercise 4, 5, and 6 at the last page, and exercise to the crossword at the beginning of the lesson. Have a nice day.